For, like in all of these other problems, we would be taking numbers and adding them together and like getting the final sum or the final product, the factorial, right? However, with reverse array, we don't really know what we should be doing, right? Because it kind of seems like we need to get the actual value out of the array and put it somewhere else, okay? So before I go on what the base case should return, I want you guys to stop and think about this. Before, in different workshops, we have done this question 2 times. The first time we did it without mutating the array. The second time we did it in place with mutating the array, okay? This question asks you how to do it without mutating the original array. So, if you were to look back and think, how would you do this without it? You would loop through the array. When you are at each element, you will start from the back, and then you will push it into a new array, and then you will return it, right? So, the same logic can actually be applied to this question. And you can actually do this question in 3 lines. And I will show you how to do that. So, if you have an entire array, and if we're going through that logic, like we need to start from the end and put things that way into an array, right? Reverse order. So that means we have to get down, we have to recursively go through the array, and then when it's at the last element, then we have to return something, because we've made it to the end, right? And the end of the array should be the beginning of the new array. So we can return the array with that element inside of it. What we want to do is return the entire array, because if we return the entire array, we can just concatenate it with what we have prior, right? I will show you, okay? So basically, we have const reverse array, right? And this is going to take an array, okay? So, our base case will be if the array.length is equal to 1. That means we have one element in our array. That means we are at our last element, right? Because since I'm telling you guys that we have to get to that last element, what we would be doing is we would be slicing off elements of the array and passing it into the recursive case, so there will eventually only be one element. And we want that one to be the last one, right? So, if this is the case, we want to not mutate this, so how can we do this? We can just return array.slice, like so, okay? Array.slice of something returns a copy of whatever that array is. And if you pass nothing into .slice, it returns the entire array as a copy. Okay, a shallow copy, but a copy. So, now we can do const result array. So, this is if there is not one thing in the element. This is if we have multiple things. So, to get our thing started, what do we need to do? We need to access the last element in the array and put it in a new array. That's what we have to do right now. So we can literally make an array literal like that and put in array of array.length minus 1. So I'm saying that now I'm declaring this array, and the thing that will be in this array is array at array.length minus 1, which is the last thing in this input array. You can also do array.slice of -1, right? This will give us the last element. I will do it this way because this is more exact, okay? So, now that we have a new array, result array, and it is just one element, we need to get the other element out, right? we need to get the thing second from the back. And if we already wrote something to get to the back, we can just slice off the last element and pass in the entire array again to reverse array. But then, how do we put that? See, the thing is like, what do we do then? Okay, sure, we pass it in, but we need to return something, right? Like, we have the result array here. So a way to do that would be to return result array dot concat, and then we would pass in reverse array invoked with array dot slice of 0 to -1. So if we call this with that, we will get 7654321. Another way to do this with the spread operator would be, just so you guys could see something interesting, would be to return a new array of result array spread out, and then this reverse array of that spread out as well. And this is the same thing. This is fancy though. Okay? This whole thing is fancy. I did this in 3 lines, right? I combined, like you could have taken out the last element and did result array equals last element in an array, or an empty array dot push last element. And then I could have done let new array equal reverse array of this, and then I could concat result array with that new array. But this is easier to do in just in line like that. So let's see what happens if we pass this in and we walk through what happens on the call stack. Okay? Let's look and see what actually happens. So we call example reverse array with example array, right? So that means reverse array will be on the call stack with 1, 2, 3. And this should return, what does reverse array of 1, 2, 3 return? So we have, if the length is 1, it is not 1, right? So we make result array, and that is an array of array.length minus 1. So that should be an array with the number 3 in it, right? So what this actually should be returning is 3 dot concat reverse array, and then pass in 1, 2. That's what's happened. So we are concatenating this 3 with the result of reverse array being called with array dot slice of 0 to -1. Everything except the last element, right? So that now we have to see, okay, what are we actually concatenating onto this array with just the number 3 in it, right? So that means this goes on the call stack. Reverse array of 1, 2. And this thing will return, so the length is not 1, so result array will be an array with the last element inside of it, right? Right? We pull out the last element here, and we say, now there is an array with that last element inside of it. So now, this thing will return that, which is an array of 2, dot concat with reverse array, and we pass in an array with just the number 1, because the last element is sliced off. Does everyone follow me up till this point? Now that I do this like this with the call stack, you see what is going on, right? You guys see how I'm getting rid of that last element. And this is what's actually happening, okay? So now, reverse array goes onto the call stack yet again. And we pass in 1. And now we finally hit the base case. Also, just to make sure everyone is aware of this, these calls of reverse array are in a state of pause. They have to wait. That is why the call stack is here. We have to know what is running at what point in time, right? But since we hit our base case, we can finally stop at least one function call, and we can get a result. Array.slice, an exact copy of that array. So that means this thing returns 1. So now, that means this is just 1. So that means this is the result of that. So 2.concat1, what does that mean? That would be 1, right? Now you see what is actually going to happen, right? So this is returned from reverse array of 1, 2. So that means reverse array of 1, 2 returns 2, 1. And then 3 concatenated with 2, 1 will be 3, 2, 1. And this is what we return from the initial call.
When you get to that final, deepest layer, the base case, whatever you're returning has to be basically whatever it would have been reduced down to, the parameter you're putting in.
The function should, and the base case should be returning the same thing. They should.
The same thing.
They should. I can't, off the top of my head, I can't think of an example where that would ever be untrue. So just make that as a rule of thumb, right?
In the base case return, mine doesn't have the array.slice, it's just return array, and it's working okay.
So
It's passing the tests.
So that can work too, because no matter what, array.slice returns a copy of this array, right? However, if we just return the real array, like the actual array, what will happen here is this will be concatenated with another array, and that returns a copy as well, if you use concat. So yes, we're doing this with just array is fine. However, to make sure you don't do anything wrong with any future data, dot slice is just a copy, right? Interesting, huh? 3 lines. That's it. Does this help you? This comment, the call stack with its return value. I recommend, even if you can't solve the problem on your own in the workshop, even if you can't go back, delete your code, and solve it again, look at the solution, copy it into a REPL, and make this little diagram, okay? Make it, and it'll help you understand what is going on. It really does, right? You can visually see it now, okay? You don't have to think about it all in your head, okay? And test it with a small input. Do you see how annoying this would have been if I tried to reverse the thing with 7? This would be 4 bigger. And that is a waste of my time, right? Any other questions? Yep.
So your base case when length is equal to 1, that's when you're returning just the array because it's just 1, right? And you're returning 1 to the result array to concat it back on, right? Because when I think of return like array, I'm thinking just return 1. You're actually putting it back onto like the rest of the.
So like reverse array of just 1 returns an array of 1, right?
Right.
So then that would be concatenated with this.
Okay.
Right?
Yeah, because when I read return, I'm just thinking just return.
You can also make this 0 and then just do the same thing, and it'll be the same thing. Because array of 1 concatenated with an array of nothing is just array of 1, right? It's just nothing. However, this is 1 extra time for nothing, you know? So we could stop it earlier at 1. Yeah.
Could you, if you did array.length equal to 0 and then just do return without returning anything, would that work? Because you're doing all
Well,
the calculations like.
Let's see what's going to happen, right? So if we do 0 and we just return, so then reverse array of 1 will return this dot concat of reverse array, and then you pass in an empty array, right? So if array.length is 0, return. What does that mean? What value is going to be returned? It will always be at least one thing. This will be undefined. So we will get undefined inside of our array. Does everybody see how this is happening? Return is definitely a good way to break a function early. However, we do get a value from there. And in our logic here, we are concatenating that value into the value of the previous function call. So concat doesn't really look at what that thing is. It just looks at the value, right? If we return yo, we will get yo inside of the array, okay? That is why.
So when you do the slide with the array that's slide, you just return the copy. Eliminates any possible new things to happen, like new values to do.
This?
Yeah.
Well, wait, what do you mean it eliminates anything?
Like you just put the copy of it instead of adding anything else.
Yes, because at this point we know there's one thing in there, right? And that, like, because this is true. Array.length is equal to 1. There's one thing in there. And we know slice returns a copy of whatever it is. And if you don't pass anything into slice,
You can
yes.
add something. Okay.
So, like, we know that this will only have one thing in there, and there won't be anything extra.
Okay.
Does this make sense? Does this make more sense now? I low-key think this was like the hardest problem in the workshop, in my opinion. So it's cool if you're a little confused. It's fine, okay? It's difficult. As long as you understand the flow of it, as long as you understand this, that is the most important thing. Knowing that these functions are in a pause state and they're waiting for something else to return so they can finally be concatenated together. Okay? That is the most important thing. The hardest part is to figure out what we need to do. However, like I said, if you guys look back on the very first reverse array problem, it's kind of the same thing, right? We make an empty array, we put one thing in it, the last thing. However, we don't have a for loop, so we're not looping to the next thing, right? That is where the recursion comes. The recursion comes instead of that loop. But everything up until that point would be the same. Is palindrome time? Time for the palindrome? The palindrome? So this question, right. So this is, you guys have done this question in the past as well. I think this is in the loop workshop. And if you guys remember, that was the first workshop I taught you guys. Time flies, right? Anyways, so this will be a function, and it will take a string. So if you guys remember, this should return true if the thing is a palindrome. You guys don't remember what a palindrome is? It is spelled the same way, forwards and backwards. The letters have to be the same. The letters, not the character code. So this should ignore case, okay? Uppercase or lowercase doesn't matter. So because uppercase and lowercase doesn't matter, we can automatically reassign string to string dot lowercase dot to lowercase and invoke that. That can be step one. We remove checking for cases immediately by reassigning the input. Okay? So, now, if you guys remember, how we did this before in a loop is we would check the first character and the last character, and then, if those were different, we would return false immediately. Because they have to be the same, right? But if they are the same, we continue, until there are either two things or one thing. If there are two things, we return if they are equal to each other or not. If there's one thing, we return true. Does everybody remember this? Okay? Because if there is one thing left in the middle, it has to be a palindrome because we have made it that far. If there are two things, we just have to check those remaining two things. So since I'm saying there are two different scenarios, that means there will be two different base cases, okay? So the first base case will be if string.length is equal to 2. And if it is equal to 2, we return string at 0 is triple equal to string at 1. We know that there are two things in the string, so we know index 0 and index 1 has a letter in it. This will return true if they are the same. If they are not, we get false. Okay? Then, right after that, if string.length is equal to 1, we return true. Because we made it to that middle, so we know everything around it has been the same. Okay? Is everyone with me so far?
I'm sorry, can you go over the return statement for the first base case again?
So this means, like if we say up here, A triple equal A, right? This will give us true. If we say let results equal A, let's show A, and then console.log results, we get true. So that means results is true. That means that this returns something. This returns true or false, right? So instead of saying like let results equal this is triple equal to that, we can just return this. We could just return this statement because that will give us a value.
I don't understand why string, like how string at index 0 and string at index 1, like in the case of any of the palindrome words, let's say A would be true.
This is a palindrome, right?
Yes.
First thing we would do is we would check and see if this is equal to this. It is. So we continue. So we're not looking at these anymore. Now there are only two things. So we have to check and see if they're equal. If this is not equal, it is not a palindrome, right? This makes complete sense, right?
Right.
Like if this was ABCA and we check AA, this is false. However, this is true.
Got it. Okay.
That's what we mean. Okay, cool. So now that we have our two base cases, right? Now we can do our logic to see like if there is more. If there is more. If we have that ABBA, right? Now we check the first character and the last character. And we see if that is true or false. If it is false, we return false immediately because it can't be a palindrome and we don't have to check anymore. If it is true, we do nothing. So we can write that like this. If string of 0 is not equal to string at string.length minus 1, we just return false. That's the only thing we're checking, if they're not equal. Because if they're not equal, then it's not a palindrome, and we can stop. If it is, though, we have to check. If it is, that means A and A are equal, right? So this is where we return our recursive case. We return is palindrome, and we pass in string.slice of 1 to -1, or 1 to string.length minus 1, right? Because slice takes two arguments, right? The first one is the starting point, and that is inclusive. It includes the element there. So that means we start at index 1, and we include it into the return value, right? That means we got rid of the 0th index. We got rid of this A. And then we stop at string.length minus 1. We stop at that last index, but that index isn't included in the result. So we get rid of the first two A's. So now, if we console.log, is palindrome of example, we get true. And if example is race car, we get true. But if this is RE, we get false. If this was a T, we get true, right? Would you like me, before any of you have questions, would you like me to do the call stack thing? Would you all like that? Okay. So I will do this with the race car example, right? But I'll make it all lowercase to save me some time, okay? So we have our call stack, right? And we call is palindrome with this. So immediately, is palindrome goes onto the call stack with the string race car. Okay? So what does this return? We have to find out what this returns so this function can stop running. We put the whole thing to lowercase, and then we say, is the length equal to 2? No. Is the length equal to 1? No. So we continue. Then we say, is string at 0 not equal to string at length minus 1? So that means if string at 0 is this R, and we check to see if it's not equal to string at string.length minus 1. So is R not equal to R? That's wrong. They are equal to each other. So we skip this return false. So that means our next thing will be, this will return is palindrome invoked with what? String.slice of 1 and string.length minus 1. I'll just make this -1 to save time. So that means we slice off. Does everyone understand how this is slicing off the first and last character? That's just how the slice method works, okay? Does that make sense? Okay, so now, so you guys understand how is palindrome of race car actually returns is palindrome of ace ka, right? Does everyone understand that? So now, since this returns a function invocation, we have to call another thing. So this goes on to the call stack. And this will be AceCap, right? And this will return what? Put the whole thing to lowercase, check its length. It's not 2 and it's not 1. So we check to see if the first letter is equal to the last letter. It is. So we can skip over this return statement because we're checking to see if they're not equal. Then we return another function invocation. Is palindrome, and now we pass in the same thing, right? The string without the first and last character. So this will be CEC. So now this has to be called, and this goes on the call stack, right? So now what does this return? We first make it all lowercase. We check to see if it's 2. We check to see if it's 1. These are both false, so we continue. We check to see if the first character is equal to the last character. C is equal to C, so this if statement is wrong. So we skip this return false. Is everyone with me so far? Everyone gets this, right? Then we return, we can go to line 27, and we return another function invocation. Is palindrome, and we pass in the string without the first and the last letter. So that means we're just passing in the letter E. So now we have hit our base case, and what do we return? Yeah, nice job, guys. We make it lowercase. We check to see if it's 2. It's not. Wait a second. We check to see if it's 1, and it is. We finally hit returning a value instead of returning a function call. That means this doesn't get reached, so that happens. So this returns true. So that means this is true, right? So that means this stopped running, and this is true. And since that returned that means this is true. And if this was waiting for this, but wait, this just finished running, so this is true. So that means this thing returns that, so that means this returns true. But now race car, the original function call, was waiting on that thing to return, and that thing just returned true. But race car returned that thing. So that means race car returns true. This one actually, I think, was easier than the concatenated array, right? Because we're working with booleans, not working with arrays. We're not working with numbers, we're working with booleans. Booleans are 50-50, black and white, one or the other. Any questions before things get more complicated? Any questions at all?
Anything that the final base case returns that just essentially just keeps getting captured as the value and being passed back.
So like if this was race car and then we had an F in here, right? We would hit this base case and we would return string at 0 is the same as string as 1. So E is triple equal to F is false. So we get false from there, and it will be passed back up to the original call. It's like you're climbing into a hole, and you have to find the actual result down there, and then you throw it back up, one step at a time. You have to dig deep and find the answer. That's what recursions are. If that makes sense. Sometimes it's hard to make sense of this, as you may have figured if I just read. So, shall we get into today's lecture? Okay. Bear with me. We are going to, first things first, I'm going to copy something into here. Cool. This is an object. Number object is one object. Okay? Right?
Yeah.
It is one object with two objects inside of it. One object has the key of A, one object has the key of F. And their values are other objects. And this will go down and down and down until we see the object with the key of D will be one object with one key, hello, and the other being 100, the value being 100. Also, we have E in 10, D20, E30 down here. So, what if I said, I want you guys to write a function that returns the sum? Get sum of this object, of all of the things that are numbers, and I want you to use recursion. And, well, okay, I didn't say use recursion. However, I want you guys to write a function that will get the sum of all the numbers. However, I will never tell you how deep the layers can possibly go. How can you possibly write this function using for loops if you don't know how deep it will go? How? Recursion. Yeah, exactly. Recursion. That's the answer.
Mm-hmm.
You use a while loop, I guess, but like recursion, right? So this is how recursion can actually seem more simple, right? If you don't know what your input could be. You don't know how deep you will have to go, right? So, let's look at this problem. Let's look at this object for a second, right? What do you guys think will be like something that could be like viewed as a base case? Not even worrying about how we're gonna like do the recursion. Like, when can we tell our function to stop calling itself? Yes.
If the thing we're looking at is not an object.
Yes. But more specifically, if the thing we're looking at is a number. More specifically, right? You could expect there will always be numbers. But he is right, okay? We will recurse through this object until we find something that is not an object. Doesn't matter how long it takes, just as long as it's not an object, okay? So, let's set this problem up. So I said already that we need to find the total, right? The sum. So I will say, let total equal 0. Step 1. We're looking good, okay? So now, we have to loop through this object. We do have to do a loop. We do. Because there's no other way to loop through the object if we don't know its keys and values, right? And this is a good way to find out, right? So we could do a for let key in obj, right? So let key in obj. Oh no. So now we can say let's current val equal obj at key. So far, so good, right? All I did was I set up a for in loop to loop through this object and say, this current value is now going to be that object at that key, right? This is fine, right? You guys are familiar with this with for and loops. Nothing weird here, okay? Now, we have if type of current val is equal to object. We will do some stuff. Else, well, I guess, yeah. I mean, it's always going to be a number. So you could just do the else. And so you could say total plus equals current val. So if it's not an object, we will just add it to the total, right? Then at the end, out here, we can return the total. So what do we do inside of this if statement? How? What should I write? Another for loop? I call get sum. What do I pass in? This? Current val, right? However, what do I do once this is done? Right? I have to store this value somewhere. So I will add it to the total. Right? So if I call get sum with number object, we get 160 because 30 plus 20 is 50 plus 10 is 60 plus 100 is 160. This, honestly, is not that complicated, right? Everything was exactly the same as if there were only two layers, right? Except instead of doing another for in loop in here, we just call the function again. So we only need one for in loop. We just need to loop through the outermost thing. Then the function will call again on that current object if it is an object, right? And then, as you can see, once we get out of there, we return the total. So this will eventually give us that number value, eventually. And we add it to the total. So, let me
why are we putting current val into get sum again? Just because we're looking for the.
Because if current val would be the current value, right? Like it'd be you have the key and you have the object, but we want the value because we want those numbers eventually, right? We check to see if it's an object. If it's not, we know that it's a number, so we pass it in. I mean, we don't pass it in, so we add it to the total, right? Because it's a number. If it's not, though, we know it's an object. So we throw that object into the function again, recursively. So then when that smaller object goes through here, we will start the for in loop in that function call with that object. So let me show you what I mean by this, okay? I think I'm missing 1, 2, 3, 4, 1, 2. It doesn't even matter, it's commented out. So this will be an example, a smaller example of this, right? So let's walk through and see what happens. But honestly, this is not that complex, right? Now that you know how to do it, I don't think that it's that complex anymore, right? So let's just walk through. So I'll write the object like this because to give us more room, so it's not spread out, right? To give us more room in the stack. So get sum is invoked with this object, okay? So that is now on the call stack. So what does that return? So as you can see, the outermost, this is an object with one key value pair. The key is f, and the value is this object, okay? So we say let total equals 0, and then we loop through that object. So that means let current value will be this object at f, right? Because there's only one thing in there. Now we say if type of current val is triple equal to object. Current val is that object. Do you guys agree? Right. So we say total, which is a 0, is now going to be reassigned to itself plus get sum of that current val. So this, right now, doesn't return anything yet, right? We first have to call get sum again. So get sum will be of another object with just b in it, and its value will be c, whose value will be another object of d, which will be 20, and then e, which will be 30, right? So now, it's a little more confusing because there's no actual return value yet, right? We're not returning anything yet. We are incrementing. So now, get sum is now invoked with a smaller object, the smaller object from the original object, right? So now we say total is 0 again, and we do a for in loop through this object. This object has one key and one value. The key is b, and the value is an object. So we do a for in loop. Let current value will be this object at b, right? Does that make sense? Is that current value an object? Is its type of an object? It sure is. So we will say the total, which is 0, will now be plus equals get sum invoked with an object with c, and its value will be another object of d, which is 20, and e, which is 30. So we have to see what this thing returns so we can add it to total. Does everyone see this pattern? Does everyone see this? So now we pass this object into get sum again. The total is again 0, and we do a for in loop through this object. This object has one thing in it as well, one key value pair. The key is c, and the value is an object, okay? The value is an object, so that means current val will be an object. So we do this 0 plus get sum of current val. So another thing goes onto the call stack. And it is an object with d as 20 and e as 30. So now, this is where things get interesting, okay? So now we call this, right? So let's see what happens when we call this. We say total is 0, and now we're going to loop through this object. Let current val equal object of key. So we will say current value of this object, the key will be d, so current val will be 20, right? Right?
Yeah.
So, is 20's type an object? No, it is not. So we go into this else, and we say total plus equals current value. Total plus equals 20. So now total is 20. Now we can continue the for in loop. Okay? There's another key value pair in here. E, whose value is 30, right? So now current val will be object at the next key, which will be 30, right? Current val is 30. Is that type of the number 30 equal to object? No. So we bypass this recursive call, and we get into total plus equals current val. The total was 20. We already did that. So now the total is 50. Okay? So now there is no longer any more key value pairs inside of this loop. So that means we can break out of the loop and we can return something. And what is the total at that point in time? 50. So that means this returns 50. So that means this thing, way back when, was waiting to see what total was being added to, right? It was being added to get sum of this. Get sum of that is equal to 50. So now total will be plus, and total was 0. So now total will be 50. So now this returns 50 as well. And this was waiting to see total plus equals get sum and pass in that object, right? But we just saw that this actually returned a value, right? This returns 50. So this will be 0 plus equals 50. So this returns 50. And this whole thing was waiting on what this thing returned. And this thing returns 50. So this returns 50, and the total was 0. So this thing will return 50. Does that make sense? Right? So the whole time we were saying total plus equals get sum of this, right? That's what we're waiting to do. That is what is going to happen. This is going to be total plus equals get sum of this. This will be total plus equals get sum of this. And get sum of this actually returns us 50. How does everybody feel about that? This was objects. There are also multidimensional arrays. However, that isn't a big deal because I checked for type of object, right? What can you do to check if something is an array? Array dot is array, right? It is very similar. The pattern is very, very similar, okay? Except a for in loop, you would use a for loop or a while loop, whatever. Whatever you feel comfortable with. Probably for loops, right? Is anyone's go-to loop the while loop? Raise your hand. No one, right? That always happens. All right, so any questions on this example before I go into the slide? This is an example from the slide, so we'll do this again. But we'll also do one from arrays, okay? And you'll get the nicer like colored tables of the call state. Okay? Cool? All right. Okay, recursion 2. So we will... All right, whatever. we're just going to talk about nested arrays and nested objects and recursion, okay? So let's look at this example real fast. We have a function that says logs an array, right? Now logs an array takes an array, and all it does is it does a for loop. It pulls the current element and puts it into element, and then it console logs that element, right? So logs an array of 1, 2, 3, but the 2 and 3 being in an array, it would log out 1, and then it would log out an array of 2, 3, right? Because this array actually has 2 elements, right? 1 and then an array. So what if the input is nested? Consider element on line 3. That could be a number, or it could be another array. If the element is an array, we want to log every number inside of it. If only we had a function that takes an array and logs out all of its values. Oh wait. We have this. Right? If only we had a function that took an array and logged out all its elements. We are using the function we just wrote, right? This is the same thing, okay? Except this takes into account if there are more arrays. So, for let I equal 0, I is less than array.length, okay? Let element equal array of I, okay, cool. Is that element an array? If it is, we call logs array again. If it's not, we just console.log. So, shit. Forgot to put this up here. So, the first thing that goes onto the call stack is logs an array of 1 and then another array of 2, 3, right? So we see 1 right away inside of the console, right? Because this if condition is not passed. This if condition says array.isArray of element. The current of element should be 1. So we console.log that element right away. So we get the 2. Now we have logs an array. This should be removed from the call stack. Now we have logs an array of 2, 3, right? That goes onto the call stack. Because that, we iterate the loop and we look at the next element. So now we have to call logs an array of 2, 3, right? Does this make sense? So now that goes onto the call stack. So now the original call of this, oh no, yeah, this shouldn't be removed. The original call of this is in pause, right? Because we have to find out what will be the result of logs an array of 2, 3. So we go through that and we get 2 because 2 is not an array, so we console.log the element. And then we get 3, which is not an array, so we console.log the element. Then, since there were only 2 things in there, we're done. That means the for loop stops and the function returns undefined. So the function stops. So logs an array of 2, 3 is taken off of the call stack, and then logs an array of 1, 2, 3 is removed from the call stack, and we have our consoles here. Does that make sense? Yeah.
So here your base case is essentially the for loop because you set it so that it's less than.
Yes.
Less than a rate.
So here, that's a good point. So you can think of the base case being the for loop, right? We're checking to see if I is ever greater than or equal to array.length. If it is, we stop the loop. However, what is really the base case would be this else statement, right? I guess. Because this is the thing that we are not doing. This is the thing that we are not having a recursive call inside, right? If this is true, else do this. We have to, it's not up to us to make this false. We are altering the input, but we have to assume that there is an end in sight, okay? We have to assume that there is, and there has to be, because infinite data isn't a real thing, okay? There's a beginning and there's an end. So, if we can assume that there is an end in sight, then we pull out that element and we pass in that inner thing, right? And that's how we alter the original array. So then, once this check returns false, we can finally not log an array. Does this make sense? So this base case is vastly different than before. I will admit that. It is vastly different, okay? However, I think like reading this makes more sense, you know? In my opinion. Like if it's an array, just do it again. Do another for loop. Just do the function again. Because essentially the function is just a for loop, right? The function is just a for loop, right? So if we find an array, just call it again with that array. That's all we're doing. And if it's not, then just like do whatever you needed to do, right? Just console.log. In this function specifically. We don't do anything. We just console.log. Easy. Cool? So, here we have an example of concat else, right? We have let final string equal a string, an empty string. And then we loop through this array, and then we add each element into that string. And at the end, we return that element. So if we console.log concat else of an array of A, B, C, we get A, B, C in the terminal, right? Easy, right? No recursion yet. But how can we do this with recursion? How can we do this if these things are actually inside of another array? How can we recursively do this? This is how. And we will walk through this solution with this. But before we walk through it, I just want to go over what this code is actually doing, right? We have the same thing, concat else, that takes an array. We have that same final string right there, right? Then we loop through that array. We check to see if the current element in that array is an array. If it's not, we just add that element to final string. If it is, we still have to add something to final string, right? Because there's an element somewhere. It's just deeper down into the arrays, okay? So that means we have to call the function again and pass that element inside. Because all this function does is for loop, right? Then, outside of the for loop, we return the final string. So, let's look at the call stack and what final string looks like at every iteration, not at every recursive call of concat else. Passing in an array with two elements, A, and an array containing two more elements, okay? So the first thing we do is we put concat else onto the call stack. Concat else invoked with this array, right? So we go through and we have final string is equal to an empty array, right? Now, for let I equals 0, let element equal array of I is this A, right? So that means it's not an array. So we go into that else statement and we do empty string plus equals A. Does this make sense? Does this make sense? We haven't gotten to anywhere difficult yet, right? This makes sense. Empty string plus equals A. That's the first thing. That's the first thing in the for loop, right? So final string is now A. We get to the second iteration of this for loop, and we get to the second element, which is an array. So now we hit this if statement. So we say final string, which is the string A, is now plus equals to concat else of an array of B and C. Does this make sense? Does this make sense? You sure? So we have to run that function, so that goes onto the call stack with B and C inside. So final string is initiated again as an empty array, and now we loop through this array, and there are no arrays in this array, so we just add B into that empty string. So the final string is now B, and the next iteration, we add C into empty string. So the final string there will be BC. Then the loop is broken out of. Then we return the final string, right? So that means concat else returns this string, BC. So if this returns BC, then back here, A will now be plus equals to BC. A plus equals BC will be ABC. So ABC is returned from that initial function call, and we take it off of the call stack. Does that make sense for everybody? You see how that was very similar to the problem I showed you with the objects, right? Except here we're checking to see if it's an array. What if, I was going to say, like, what if you didn't know if the element was an array or object, right? You would first check for the array, then you would have an else if. You would check for an object. And if it's an object, you would do a for in loop, and then if that thing is an object or an array, you would call the function again. You know what I mean? It's just a combination. Yeah.
So the base case is the else. Is that what you're saying?
I guess so. You know? Like, it's vastly different to think about, right? Because we're not reducing something. You know? We're not, like, reducing something until, like, the number is 0 or the length is 0 or something. The number is greater than 10, whatever. We're simply doing this until we don't find an array.
So you don't have to hit return.
We do.
There.
We have to hit return if we want to get that value of the BC back, right? Before, in logs and array, we didn't, because all we were doing was console logging. Console logs happen instantaneously, right? If you were to console log and you were recursing through, like, going through 10 steps, you'll see, like, 10 million console logs, right? But returning something, we actually have to get something back, because the whole time that this was running, it was actually running because we were waiting for A plus equals whatever that returns, right? So what are we going to add onto the A? We need a return value from that, which was BC. So now that we finally got that, A plus equals BC, we can go forward, and then that was the last element in this for loop, so the for loop breaks out, and we get our final string. Does everyone see the logic behind this? If it's an array, call the function again. If it's not an array, just add it to the string. That's really all there is behind this. Any questions? Yeah.
So I guess for me, like yesterday when we were talking about recursion for the first time, I was thinking for some reason our recursion as like a way of not using like loops and just using like calling the function within the function. But then now I guess I'm gaining a deeper. It's not just like I guess you use the function itself when you don't have to use a for loop. But it's like incorporating.
You were using them together now.
Yeah. But now you can incorporate and just like minimize the amount of for loops you do by calling the function itself.
Yes.
Okay.
100%. I mean, you technically are calling the for loop a million times, but just in different instances of that function, you know?
Okay. So you're still pretty much doing a for loop when you call the function, but it's just in a different way.
Exactly.
Okay.
Like, also, like, any problem you can solve with loops, you can solve recursively, right? So, I don't want to get into this because it is a massive headache, but we could probably do this problem with just recursion and no outer for loop. Probably. I'm not going to sit here and try to figure it out in front of you because that would be an immense waste of time of yours and mine. Okay? Yeah.
I was looking up different problems to kind of this, and some people have used like for each to kind of do So like in after result, is it like if
So like for each would be array.for each. You would have the current element already because that's passed into your function. So in your function you're passing into for each, you would check and see if that element is the array. Then you would call concat else again. Otherwise, the if else statement should be the same thing. Should be, if you're using for each. Because one for each is like a for loop, one for loop, right? Any more questions on this example? Cool. So we are going to run through. So we are going to run through nested objects a little more quickly because I already showed you this example. Okay. So working with nested objects is very similar to working with nested arrays. Use a for in loop to iterate through the object instead. If the value is another object, recursively call the function on the nested object. So here we have the same thing, okay? Except this isn't using recursion, right? Because we don't have a nested object. We simply just do a for in loop, we take out the value and add it to the sum, and at the end we return the sum. Is everyone okay with this? This is not taking into account nested objects. This is just looping through an object and adding all the number values together, right? So, here is like the example I showed you, right? This, we have a really big mess of an object, and now we do a for in loop through the outermost object first, right? Because really this object has just two key value pairs, right? A, which is a number, and B, which is an object, right? So we just have to loop through that. We take out that value, we check to see if it's an object. If it's not, we just add it to the sum, and if it is, we add something to the sum, but we have to wait and see what we get, because we have to call that function again, but pass in that object. Right? So, here we have the call stack again. We have some vals passed in with this object, the outermost object, and the sum at this point is initiated at 0, right? So, as you can see, we have this A1 and then B object, right? So, once we hit that A1, we get 0 plus equals 1. Because in this for in loop, object at key, object at A will be 1. 1's type is number, not object, so we go into the else. Sum plus equals value, sum plus equals 1. 0 plus equals 1. So the sum is now 1. Okay? Does that make sense? Right? Nothing weird yet. So now we have to do the next iteration of that for in loop, and the next key value pair will be B with the value of object. So the value will be object at B, so the value is actually this object. That type is object. So now the sum, the current sum is 1, will be plus equals to some vals of that object, right? So then that goes on to the call stack, and the sum is again initiated at 0. And we pass in that object, right? So now we loop through this, and we say, okay, the current value will be object at key, object at C, right? So that means that object. So we do 0 plus equals some vals of that object. And so on, so forth, right? Oh. Computer is pretty slow right now. So as you can see, we go deeper and deeper into the objects until finally we reach one object up here with no nested objects. So that means this if statement will actually never be reached. And instead, we can take the values and add them into the sum, which in this function invocation up there was 0, right? It's still 0 up there. So we do 0 plus equals 2. Because the key in that point of time was e, so its value is 2. So we do 0 plus equals 2. So the sum is now 2. We continue the for and loop to get to that f3, right? So we do 2 plus equals 3. So that means the sum is 5. So that means we are done with the for in loop. We break out of it, and we return the sum. We return the sum. So that means this returns 5. And this is this, so this returns 5. So 0 plus equals 5, right? Does that make sense to everybody? Cool. So now that this returns 5, this returns 5, and this is the same thing as this, so 0 plus equals 5. Right? So now the sum over here is 5. And this is the same thing as this, and that returns what? And that returns 5. So now the sum back here was 1. So 1 plus equals 5, we get 6. And this finally returns 6. So this function can finally be taken off the call stack, and we have our value. Does that make sense? I went through that a little quickly, but this is the same example I showed you before we started the slides, right? And you can see that it's the same concept as the arrays. Yeah.
Why isn't the sum 1 the whole time until it gets added on? Because of the first
So the first
time
time,
it went through.
right? Like the sum is 1, right? And then when a we get the value at key a, and we put 1 into the sum. 0 plus equals 1, sum is 1. Then we hit b, right? So now we have to do 1 plus equals, the function is getting called again. If the function is called again with this object, we pass this object into here. The first line is let sum equal 0. The sum is 1 when this was called. However, this is a new function call, a new instance of that function. So that means that the sum is now 0. And that sum, that 0, will be plus equal to whatever the value of that b is, right? So it will be 0 and 0 until we get to these innermost values here, the 2 and the 3. Because there are no more objects, so we can get that 5, add it to the sum, and then return the sum from that topmost function, the topmost function call up there. Then since that returns 5, we can finally do 5 plus equals sum, because the one before that has been waiting all this time for that thing to finish. So that 5, that deep down 5, gets pulled all the way back to the original function call, which was this, where the point in time, the sum has always been 1, right? And it's just waiting. It's just been waiting for all of these function calls to finish. And it actually spit something back. It spit back 5. So then 1 plus 5, we get 6. Like every time you call the function again, the sum is 0. That's the first thing that happens. Sum is 0. We set a sum and it's 0, right? When we call it here, the sum in this function has absolutely no reference to the sum when we call it with this other object, right? They're two different function calls. Does that make sense? Does that make more sense? Does that make sense to everybody? How's everyone feeling? Yeah.
Question in the if statement, why is it plus equal instead of just equal? I know it's like calling
Well,
the function again. But
If we just like, okay, let's say we just got down to the 2 and the 3. If it was just equal, then sum would now be equal to 2. And then when we got to the 3, it wouldn't be 5. Sum would just be equal to 3. You know?
Yeah.
The point is to get the sum, so we have to add instead of
Got it.
just reassign.
Right, and that's going for each key.
That's
Okay,
for everything.
okay.
Unrelated but an object question. If you wanted, instead of object at key to point at it's pointing at the value.
Yeah.
What if you wanted it to return the actual key? How would you write that out?
Key.
You don't have to write object key.
You have the key. The key is the key. Like, before this line, if I was to just console.log key, that'd be the key. You could say let mu key copy equal key, right? That actually confuses people sometimes, you know? Because it's like, all right, where do I get the key? It's right there, and it will always be there, and it will always be different in every iteration of the for loop, automatically. For loops are nice, you know? It's just like that. Very similar to a for each, right? For each just gives you the element, right? You don't have to do like at I or anything. You just get the current element. Very similar to here. You get the current key. And you use that current key to get the value, okay? Yeah.
So let's say instead of wanting to take the sum of all of the numbers, we wanted to count how many numbers there are. Is the only change that would be made in theory is in right. It
This
just
would be plus
one.
plus,
Oh,
or plus 1. Same thing.
and that would give us a count instead of.
Yeah.
But the line where the function's called, I guess the recursion line, that one doesn't change. That one's still plus equals.
Yeah.
Okay.
Because think back to here, we have 2 numbers down here. So we skip the recursion line and we do plus plus twice. So we have 2. We need that 2 to stay the same,
Right.
right?
Yeah.
Good question. Any other questions? You guys are ready? So we got 6. So we talked about nested data structures in recursion with nested arrays and nested objects. That is the last lecture. That's it. You guys don't have to listen to me talk. No, actually, no. I have to talk to you guys tomorrow. But that's the last lecture. Any final questions before I split you guys up into pairs? Well, after you take a break.
Are you going over HackerRank?
Tomorrow.
How long does the assessment usually take?
You were timed at like 70 minutes or something like that.
Oh, okay. So it is time. Okay.
So you guys get the full 70 minutes. We'll talk about that tomorrow though. Before you guys take the test, like we'll talk about the test, talk about the second test, talk about the interview, talk about anything you guys want, like full stack admissions related. Like I said before, there's gonna be pizza, so don't eat dinner. Cool.
So there's no like referencing, like when we're taking the test, like we can't like reference notes, obviously.
So I mean, like, it is a practice test, and full stack won't look at it if you do well or bad. So you can close the screen and then look up stuff if you want to, if you're really stuck. I personally recommend you do nothing like that because I think it is more beneficial to all of you to instead use the first practice test as kind of like a mental mark to see where you need more practice, where you need to study more, what areas of computer science you are still struggling with, okay? And that is impossible to identify if you are looking shit up, right? So, I mean, honestly, like, looking things up is like how you become a good developer. Like, you have to self-teach yourself. I can't teach you everything. I don't know everything. There isn't one person that knows everything about computer science, right? You have to look things up all the time. Half the job is Google, honestly. Seriously. However, for this specific, this is very fundamental, basic level stuff. So this, you do have to put in a little work. You have to put in a little groundwork and really solidify your understanding on some specific concepts, okay? And the practice assessment that you take in class tomorrow will be a good way to measure what you guys are lacking and what you guys are good at, okay?
So at the end of it, we'll be able to see everything again and practice everything we lack. Like at the end of it, we have all the results and stuff, and we can use.
Yeah, you'll get the solutions for practice assessment 1 for sure.
Okay, cool.
So you'll see like the
So they're gonna
solutions.
be different tests?
Hmm?
They'll be different,
What do you mean?
like assessment 1 and assessment 2.
Yeah, different
Oh,
tests.
okay.
And you won't get like the answers for
The second,
the second one.
but it's gonna be similar like concepts and.
Yes.
Okay.
Like in CodePen, how you know if you're like passing the test or not, is that element? Is that like part of it as well, or you're just spitting out code? And
No. You'll see some test cases, for sure. Like you'll see. You'll know what you're passing.
So
You'll know
like,
what you're failing.
why go on to number 2 if you're failing number 1?
Well, because there's like 30 test cases, and like if you're passing 27 of them and you're running out of time, like you know,
Right.
partial credit is fine. I'll talk more about this in depth tomorrow, for sure.
Okay.
I promise. I'll answer more questions about this tomorrow. But you guys need to start the workshop because it's cutting into some time. All right? Is everyone okay with this? Probably not, but like you'll get there. All right, so take a break. I'll slack out pairs in like 5 minutes. All right?